let me revise. So we were studying Newton's laws. We studied already two laws of Newton, Newton's first law and Newton's second law. Newton's first law is about when no force acts on a body, what happens? Now the body remains at rest or moves with constant velocity. Newton's second law is about when force acts on a body, what happens? So the answer is body accelerates, and acceleration is given by F by m. So before Newton, people thought that out of these four cases, before Newton, people thought only this one case is related to no force, and the other three cases are related to force. But after Newton, now we understand that no, first two cases are related to no force, second two cases are related with force. So no force means the body can be at rest or can move with constant velocity. Force means it can accelerate like that. And then now we were studying Newton's third law, and before studying Newton's third law, we were discussing about the forces in nature. So there are four major forces in nature: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Under electromagnetic force, we have electrostatic force or Coulomb's force, magnetic force, spring force, tension, normal reaction, friction. Now we will be studying each force in detail. So to study each force in detail, we will ask these three questions: when this force will act, how much this force will act, in what direction this force will act. So yesterday we discussed about gravitational force. Today we will discuss about other forces. Chalo. So yesterday we had discussed about gravitational force, right? Today we will discuss about other forces. Okay, gravitational force. So gravitational force, when this force acts, any object, whoever is having mass, it will apply gravitational force on others, and others will also apply gravitational force, so it will experience gravitational force. So gravitational force acts on whom? It acts on bodies having masses. It acts on bodies having masses. मास है मतलब ग्रेविटेशन फोर्स लगेगा, मास नहीं है तो नहीं लगेगा. Okay, next. How much? Theoretically speaking, every object is applying gravitational force on body, but we will consider gravitational force only due to Earth, so its magnitude is mg. Third question: what is the direction? Direction is towards center of Earth. Towards center of Earth. This much we had discussed yesterday. Towards center of Earth. अच्छा, देखते हैं आप लोगों को याद है कि नहीं. So this is Earth. This is Earth. Here is a body. Here is a body. Tell me, in which direction gravitational force will act on it? This direction, isn't it? This direction. Yes, if the body is here, let's say this is body A, let's say this is body B. So now on body B, in which direction gravitational force will act?
Leftward.
Leftward, like this. If there is a body C here, in which direction gravitational force will act? Upward, yes. So don't tell that gravitational force acts downward. The exact answer should be gravitational force acts towards center of Earth. But yeah, in general, we saw ground like this. In general, we saw the ground like this. And then we keep a body here. In general, we keep a body here. Then if I ask what is the direction of gravitational force, then you can tell downward. But otherwise, don't always tell downward. Sometimes it can be leftward, rightward, upward. Especially when we are studying gravitation chapter, there we will come across such diagrams. So there we have to tell that gravitational force is acting for center. There if you tell gravitational force acts downwards, तो फिर गलत हो जाएगा. ये B के ऊपर downward थोड़ी ना लग रहा है. B के ऊपर थोड़ी ऐसा downward लग रहा है. या C के ऊपर थोड़ी downward लग रहा है. Getting it? But in this chapter it's okay to tell downward, because in this chapter you will find the ground is downward. So here, if I ask what is the gravitational force, then you have to show me like this, mg. And what if I give a question like this? This is ground. This is ground. This is inclined plane. Most of the time, question comes like this. This is the inclined plane, and here the body is kept. So tell me, what will be the direction of gravitational force? Option 1, this one. Option 2, this one. Tell me, gravitational force किधर लगेगा? Option 1 या option 2?
Option 1.
Option 1.
Sure.
Option 1.
Why not option 2? Why not option 2? Because Earth is not that side. Center of Earth is not that side. Center of Earth is this side, na? This is the Earth, na? This is the Earth. This is the Earth. Clear? So be careful. Be careful. Many times people draw it towards second direction, towards 2. That's wrong. Acha. So I think we have completely properly studied gravitational force. Now let's go to electrostatic force. So the next one is electrostatic force. Chalo. Next लिखो electrostatic force. Acha. So the first question, on whom electrostatic force will act? On whom? So the answer is on a charge. On a charge. The electrostatic force acts on a charge. Acts on a charge. So if your body is having some charge, then gravitational force will act. If there is no charge, then gravitational force will not act. Sorry. If there is charge, then this electrostatic force will act. If there is no charge, then electrostatic force will not act. And what is this formula? What is this formula? Its formula is, if there are two charges, then we use this formula. 1 by 4 pi epsilon naught q1 q2 by r square. है ना? If the question is given that there are two charges, the separation between them is r. The separation between them is r. Like this. Then force will be k q1 q2 by r square. And because of this force is also called as Coulomb's force. This force is also called as Coulomb's force. This comes in 12th class first chapter, but the theory comes here. Achha, or we can also write down force as QE. Force as QE. Let's say here is an electric field E, and here I keep a charge Q. Then the force acting on it will be Q into E. Is that clear?
Yes, sir.
Okay, so you remember both these formulas. You remember both these formulas. If we have to find force between two charges, then use k q1 q2 by r square. But if the question is there is an electric field and a charge is kept, then how much force? Then QE. Details about this you have studied in 12th class first chapter. Okay, now next one is magnetic force. Next one is magnetic force. So the question is, on whom this force acts? This force acts on whom? अच्छा ये फोर्स का तो मैग्नीट्यूड लिख लिए, डायरेक्शन भी आपको पता है ना? इलेक्ट्रोस्टैटिक फोर्स का डायरेक्शन क्या होगा? लाइक चार्जेस रिपल, अनलाइक चार्जेस अट्रैक्ट. और इलेक्ट्रिक फील्ड में रखेंगे तो क्या होगा? पॉजिटिव चार्ज के ऊपर इलेक्ट्रिक फील्ड के डायरेक्शन में लगेगा, नेगेटिव चार्ज के ऊपर इट विल एक्ट ऑपोजिट टू द इलेक्ट्रिक फील्ड. ओके, नाउ कमिंग टू मैग्नेटिक फोर्स. मैग्नेटिक फोर्स, इट एक्ट्स ऑन whom? It acts on whom? Anyone knows magnetic force acts on whom? Who can tell? You should know now when a force acts, when a force does not act. Who can tell when, on which body magnetic force acts? Yes. No one. No one. Hello.
On a magnet or a charged body.
Yeah, on a magnet. You can tell on a magnet. That's why the name is magnetic force. What else? It acts on a current carrying wire. On a current carrying wire. What else? It acts on a moving charge, not rest charge. Huh? It acts on a moving charge. Moving charge. If the charge is at rest, then this magnetic force will not act. It acts only when the charge is moving. So what is the formula? What is the formula? On a magnet, the formula is force equal to pole strength into magnetic field. Just like here, it is charge into electric field. Here it is pole strength into magnetic field. And so on a current carrying wire, force equal to I L cross B. If you remember 12th class chapters. And on a moving charge, if you remember 12th class chapter, it is force equal to Q B cross B. Q B cross B. कुछ याद आया क्या?
Yes, sir.
अच्छा, so if you understood this, raise your hand. Okay. What was the next force? What was the next force? This was electrostatic force. This was magnetic force. Next, let's go spring force. Spring force. Okay, when spring force acts. First question: when spring force acts? So the answer is it acts. It acts if the body is connected to a spring. If the body is connected to a spring, and the spring is stretched or compressed, and the spring is stretched or compressed from its natural length. Compressed from its natural length. From its natural length. ठीक है, सिर्फ स्प्रिंग के साथ अटैच होकर रहने से नहीं होगा, वो या तो स्ट्रेच होना चाहिए या फिर कंप्रेस होना चाहिए, है ना? Then only this force will act. So let's do three cases to understand it. Let's do three cases to understand it. First case. First case. Let's say this is the spring. This is the spring. And let's say the spring is at natural length. Let's say the spring is at its natural length. Let's call L0 as natural length. L0 as natural length. तो पहले स्प्रिंग नेचुरल लेंथ पे है L0. अच्छा, will this spring apply force? Will this spring apply force?
No, sir.
अच्छा, no. Now let's take this case. Now let's say the spring is like this. Now let's say the spring is like this. है ना? अच्छा, now see how much the spring is stretched. How much the spring is stretched? This much. This much the spring is stretched, isn't it? This much is natural length L0, and now it is stretched by x. So what is the final length? Final length is L0 plus x. But the spring force does not depend on final length. The spring force depends on how much is the extension. So the spring force will be k into x. As in which direction? The direction will be such that it wants to comes to natural length. Achha, it wants to come to natural length. That means now the spring is trying to come to. Now the spring is trying to move which side? Now the spring is trying to move which side? Left side or right side?
Left side.
Left side.
Achha, left side. So the force, let's say this is the magnitude of the force, 5 Newton. So now if I have to write it, you know which sign, I have to write it as minus 5 Newton, because it is 5 Newton towards left. So if you write with sign, then we should write it as minus x. If you write with sign, then we should write it as minus x. समझे क्या? If you are not interested in direction, if you are interested only with the magnitude, then just tell k into delta x. Many times people tell k into delta x. That k is called as spring constant. K is called as spring constant, that is proper to the spring. है ना? Now let's say the spring is compressed. Let's say now the spring is compressed. So see how much it is compressed. Let's say now the spring is compressed by this much. So now force can be written as minus kx. So you remember this formula: force equal to minus kx. Many times it is written as force equal to k into delta x. K into delta x. Okay, now what is the difference between these formulas? You try to understand. बहुत सारे बच्चों का यहाँ confusion होता है. अच्छा, when we write k into mode of delta x, here the meaning is k into elongation or compression. So here you take the positive value only, and here F will always be positive. So here basically we are writing only the magnitude. And the direction, either we are telling it in words or we are telling it by putting a direction, an arrow. But when we write like this, that means we are telling the magnitude and direction together. Like there are two ways to mention vector quantities. Not two ways, actually there are three ways. See, when you have to mention vector quantities, then it is your choice whether to tell the direction or not. But yes, if you are putting the value in equation, then you must put with sign. But if you are not putting the value in equation, you are just mentioning, then you have a choice whether to tell the direction or not. So you have a choice to tell whether whether to tell the sign or not. So sometimes people may write f equal to kx, sometimes they may write f equal to minus kx. But whenever you have to put it in equation, you have to put f equal to minus kx. Otherwise, there will be mistake. समझे क्या? And writing like this, basically this includes magnitude and sign. For example, generally what we do, we take this as our origin and this is our positive direction of x-axis. अब यहाँ पे देखो, here the body is displaced towards right. So x is a positive number or negative number? Its new position is x. X is a positive number or negative number?
Positive.
So you put x as positive. K is positive. So x and k both are positive. So this f comes out to be negative. That means the force is towards left. Okay. Now here this is the origin. So here the body is here. The spring is compressed. So x is positive or negative?
Negative.
Negative. So put x as a negative number. So this negative number and this minus together this becomes plus. So force is plus. Plus means here force is acting towards right.
Right.
In that sense, that minus is used. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
But if I only ask you magnitude, then just take the mode of x, take mode of delta x or mode of x, and then do k into x. है ना? चलो एक example दे देता हूँ. It's like this. Okay. Let's say this is the natural length. Let's say k equal to 100 Newton per meter. Now the body is where the body is. The body is here. This is like origin. This is the positive direction of x-axis. Now the body is here. So this is now the body is at x equal to minus 5 centimeter. If I ask how much is the force, then your answer will be f equal to minus kx minus k is 100 Newton per meter into minus 5 centimeter. So minus 5 centimeter means 500. So this comes out to be how much? 5 Newton. So it came out to be plus. That means I will tell the force is, the spring force is how much? The spring force is 5 Newton towards right. समझ में आया?
Yes, sir.
But let's say I am not bothered about sign, then I will just tell, oh, k is 100, oh, x is 5, so k into 5 by 100, so it's 5. So I will tell the spring force is 5. And what is the direction? Okay, direction I will find separately. Okay, I will tell the spring is compressed. Since the spring is compressed, it will try to come to natural length. So the spring must be pushing the block towards right. So the spring force is towards right. And like that. अगर स्प्रिंग फोर्स के बारे में समझ में आ गया, ये प्लस और माइनस के बारे में समझ में आ गया, then raise your hand. ओके मैडम किरण ज्योति श्रावणी ईशानी प्रयास कमलेश शुभश्री स्वागत भव्या ओके ओके ठीक है. So this was about spring force. Okay, this was supposed to be close. Okay. Chalo, I am giving you some questions. Show me spring force. Show me the forces acting on a body. So write down next topic. Likho FBD. FBD means free body diagram. Free body diagram. What is the meaning of free body diagram? Free body diagram means you take one body, don't take all bodies. Take one body and then show all the forces acting on the body. All the forces acting on that body. Don't show the forces this body is applying on others. And what you have to show? You have to show which are the forces acting on this body. That means others are applying on this body. For example, question number 1 there. Question number 1. Achha, here that block is hanging. Tell me, what are the forces acting on the body? Achha, how to find out? Remember the list of forces. Force number 1, whether it is acting. If it is acting, how much, which direction? Force number 2, whether it is acting. If it is acting, how much and in which direction? Force number 3, whether it is acting. If it is acting, how much in which direction? Like that you should solve. So for this, you must remember the list of the forces. Otherwise, you can't solve. So tell me, chalo, question number 1 solve karte hain na? Question number 1. Question number 1, chalo, which is the first force? Which is the first force in the list?
Gravitational force.
Gravitational force. Is it acting? Will gravitational force act on this mass?
Yes, sir.
Yes.
Yes, sir.
Yes. How much?
MG.
Which direction? Which direction?
Downward.
Downward.
Downwards. अच्छा ठीक है. What is the next force in the list? List में next force क्या है?
Spring force.
Electrostatic.
Electrostatic force. अच्छा, electrostatic force acts on which body? Body having charge.
Charge.
Is this body having charge?
No, sir.
So will electrostatic force act?
No, sir.
No, sir.
So what is the next force? It is magnetic force. Magnetic force, it acts on which body?
So magnet or charged body or moving charge?
Yeah, it acts on magnets, or it acts on moving charges, or it acts on current carrying wires. Is this block any one of those? No.
sir.
No,
So
sir.
will magnetic force act? No.
No, sir.
No.
Acha, what is the next force?
Spring force.
Spring force. Acha, will spring force act on this body? Is it connected to a spring? Yes,
sir.
it is connected to a spring. Acha, is the spring compressed or elongated?
Elongated.
Elongated.
Yeah. So spring force will act. Spring force will act in which direction?
So upward.
Upward. So spring force will act in upward direction. अच्छा, how much? K into x naught.
X.
मान लेते हैं कि इसका नेचुरल लेंथ यहीं तक था L naught, and now it is elongated by x naught. So spring force is kx naught. So simple ना? है ना? अच्छा, question number 2 पे आ जाओ. Question number 2 पे. Question number 2. Force number 1. Gravitational force. Will it act?
Yes, sir.
Yes, sir.
Yes. So it's mg. Mg. Force number 2. Electrostatic force. Will it act?
No, sir.
Force number 3. Magnetic force. Will it act?
No, sir.
No, sir.
Force number 4. Spring force. Will it act?
Yes, sir.
Yes, sir.
So apply spring force. So the spring is compressed. So now it will be acting upwards. So let's say this was original length L naught, and it is compressed by this much x naught. So how much it will act? K x naught upwards. समझ में आया how to draw free body diagram? This is a very important part in physics.
Yes, sir.
Every question you have to start from here. Anyway, now we have not studied much. We studied only 4 forces, है ना? So now let's go to the next force. Let's go to the next force. Next force क्या था? Electrostatic हो गया, magnetic हो गया, spring force हो गया. What is next? What is next?
Tension.
Magnetic हो गया. Tension. Tension. चलो next force लिखो tension. Tension. यहीं पे लिखो. Tension. As a tension. When does tension act? So it acts on your body tied to a rope. acts on a body connected to rope, connected to rope, and rope should be tight, and rope should be tight, otherwise it won't happen. टाइट को फिजिक्स के लैंग्वेज में टॉट भी बोलते हैं, टॉट. In some books they write taut, so taut means tight. So the rope should be tight. अच्छा, how much इसका मैग्नीट्यूड फिक्स नहीं है. It can be anything. It depends on other forces. It depends on other forces. It depends on situation. So this is called a self-adjusting force. It is a self-adjusting force. Self-adjusting force. That means it adjusts its value according to situation. Its value is not fixed. So what is direction? Its direction is along the rope. Its direction is along the rope. Along the rope. है ना? रोप ऊपर की तरफ लगा है तो ऊपर होगा, रोप नीचे की तरफ लगा है तो नीचे होगा, रोप राइट की तरफ लगा हुआ है तो राइट की तरफ होगा. इज दैट क्लियर? रोप 30 डिग्री एंगल पे लगा हुआ है तो 30 डिग्री एंगल पे होगा, है ना? But only thing is that it can only pull, it cannot push. It can only pull, it cannot push. It cannot push, है ना? So example, let's say it's like this. चलो, on this body, whether tension will act? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Which direction? Which direction?
Upward.
Upward.
Yeah, so upward. And its value, let's name it as T only. mg will act downwards, है ना? mg will act downwards. Its value can be anything, depends on situation. अच्छा, look at this figure. Look at this figure. Many times you come across this figure. M1, M2. अच्छा, on M1 body, tell me which force will act? M1, which force will act?
Gravitational force or
Gravitational force नीचे, और tension?
Yes, sir.
Tension?
Sir, upward.
Upward, yes. अच्छा, on M2, which forces will act? Gravitational force downward, tension?
Upward. Sir, upward.
Tension? Upward. रोप ऊपर लगा है तो टेंशन ऊपर ही होगा. सिंपल, है ना? Look at this. This is a 4 kg body. Let's say I'm pulling it like this. I'm pulling it with a rope. Let's say I'm pulling it with a rope. है ना? With how much force I am pulling it? Let's say I'm pulling it with 50 Newton. So now, let's say this angle is 60 degree. Is tension acting on the 4 kg block?
Yes, sir.
Yes, because it is connected to rope, so tension is acting. Now, the tension is acting in which direction? It's acting along this direction. You have to show it like this. समझे क्या? रोप जिधर कनेक्टेड हुआ है टेंशन उधर लगेगा. अच्छा, यहाँ पे टेंशन कितना होगा? 50 होगा. Because I am pulling it with 50 ना, then tension will be 50. So tension with the star mark देके लिख दो. If the rope is pulled with a force F, then tension in it will be F. If I pull it with 60 Newton, tension will be 60 Newton. If I pull it with 100 Newton, tension will be 100 Newton. Got it? It adjusts its value like that. तो स्टार मार्क देखिए क्या लिखोगे? लिखो, if the rope is pulled with a force F, then tension in it will be F. हाँ. लिख लिए क्या? If a rope is pulled with a force F, then tension acting on it will be F.
Yes, sir.
Okay. Okay. चलो. There are some more things on. So लिखो important points about tension. First point क्या लिखे? First point लिखे if the rope is pulled with force F naught, then tension in it will be F naught. Then tension in it will be F naught. Next point लिखो. Next one लिखो. If the rope is massless, then tension in it will be equal. Then tension in it will be equal at every point. Equal at every point. Next लिखो. If the pulley is massless or frictionless, then tension will be equal on both sides. Okay, what is the meaning? I'm telling you. So let's say these are the blocks M1 and M2. So I said that, you know, let's say case one actual rope is massless, and then pulley is also massless. Or frictionless. What is the meaning of this? Are you able to see my laser light?
Yes, sir.
Okay. Now rope is massless means tension is same everywhere. Here also. Tension will be same at every point. It will be T. It will be T everywhere. If the rope is massless, that's the meaning. If I tell no, this rope has mass, then tension here will be T1, T2, T3, T4. Tension at every point will be different. Got the meaning of first this one? इसका meaning समझ में आया? रोप का massless होने से नहीं होने से क्या difference है? If the rope is massless, tension at every point will be same T. If the rope is having mass, then tension will be different at different points. T1, T2, T3. यहाँ पे T लूँगा तो यहाँ पे T1 लेना होगा, यहाँ पे T2 लेना होगा. If I take T everywhere, then it will be wrong. समझ में अगर आया तो हाथ उठाओ. अच्छा, I was telling the difference between rope being massless and rope having mass. Okay, next. What if the pulley is massless or frictionless? Acha, If the pulley is massless or frictionless, then if you take this side tension T, left hand side, then on the right part of the rope also you should take tension T. It is same everywhere. But let's say he tells no, pulley is having mass, pulley is having friction. Then if you take this side T1, this side you have to take T2. अगर समझ में आया तो हाथ उठाओ. Now for this case 1, my diagram should be like this. Now I have taken rope as massless. तो यहीं पे अगर मैं टेंशन को T लिखूंगा तो यहीं पे भी T ही होगा. अच्छा, the pulley is also massless. So if left hand side it is T, then right hand side also it will be T only. अच्छा, again rope is massless. So if it is T above, it will be T here also. So in my diagram for M1 my tension will be T, and of course here M1G. For pulley the tension will be T here, and here some force, that is connected. That's connected here, na? So that to whichever it is connected, that is applying some normal reaction. That I will tell you later. And for the mass 2, again here also it will be tension will be T only, and this is M2G. Got it? This
Yes,
is the
sir.
meaning of case
Yes,
1.
sir.
अच्छा, इसको थोड़ा चेंज कर लेते हैं ना, केस 2 कर लेते हैं. क्या केस 2 rope is massless, but pulley has mass and friction. अब क्या करना होगा? अच्छा, अब यहाँ पे अगर टेंशन T लेंगे, रोप इज मासलेस, तो यहीं पे भी टेंशन T होगा, बट इस तरफ टेंशन T डैश लिखना होगा. T लिखने से गलत हो जाएगा, बिकॉज पुली इज हैविंग मास एंड फ्रिक्शन. तो ऑन बोथ साइड्स इट विल बी डिफरेंट. तो पुली के लिए डायग्राम T और T डैश हो जाएगा. फिर लेफ्ट हैंड साइड T डैश हो गया ना, तो हियर also it will be T dash. This one it will be M1G, this one it will be M2G. If you understood this case 1, case 2, raise your hand. Now let's say I make case 3. Case 3, rope is also having mass, pulley is also having mass and friction. फिर क्या हो जाएगा? चलो ड्रॉ करो, इसका ड्रॉ कर लो. केस 3 इसका खुद ड्रॉ करो. Rope has mass, pulley also has mass and friction. Pulley also has mass and friction. अच्छा, अब देखो हर जगह पे टेंशन अलग हो जाएगा. यहीं पे मान लो टेंशन T1, here it will be tension T2, here it will be tension T3, here it will be tension T4. If you understand this, raise your hand. Case 3, if you understand, raise your hand. Okay, now no need to worry. Generally we will deal with case 1 and case 2. In this chapter, all the questions what we will solve questions from case 1. And in rotational motion chapter, we will come across some questions where we will deal with case 2. So no need to worry about other cases. We will deal with case 1 and case 2. समझ में आ गया क्या?
Yes, sir.
Sir, yes, sir.
How many forces completed? Count. Gravitational force हो गया. Gravitational
Yes,
force,
sir.
electrostatic force, magnetic force, then spring force,
Green.
then tension.
Tension.
Yeah,
5 force.
five forces. Achha, now write down one more. Write down normal reaction. Normal reaction. Achha, so again the question, when it will act? It acts when bodies are in contact with each other. It acts when bodies are in contact with each other. So when does normal reaction act? Normal reaction acts whenever bodies are in contact with each other. Contact में होना चाहिए तभी लगेगा, इसलिए ये फोर्स का नाम कांटेक्ट फोर्स भी है. स्प्रिंग फोर्स, टेंशन फोर्स, नॉर्मल रिएक्शन, फ्रिक्शन, ये चारों को we call them as contact force because these forces act only when bodies are in contact. Magnetic force, gravitational force, electrostatic force, they act from distance also. That's why they are called as field forces. So force can be divided in according to this also. You know? Anyway, normal reaction. It acts when bodies are in contact with each other. And so what is the magnitude? Oh, it can be anything. It is self-adjusting force. It is self-adjusting force. It is self-adjusting force. Acha, what will be direction? Look at its name. In its name only there is the word normal. Mathematics में आप लोग पढ़ाई किए थे ना, normal का क्या मतलब होता है? Perpendicular. So it acts perpendicular to surface of contact. It acts perpendicular to surface of contact. Acts perpendicular to surface of contact. अच्छा, याद कर लो, this is a pushing force. This is a pushing force. That means it can only push. It can only push. अच्छा, anyone has any question? Someone is raising hands. किसी का कोई क्वेश्चन है? अच्छा ठीक है, चलो चलो तो नॉर्मल रिएक्शन को आइडेंटिफाई करो. Here is a block, block A. Here are two blocks, block A and block B. Here is a wall and here is a rod. You have to identify how many normal reactions are acting and in which direction. Here is another wall. Here is a sphere. Here is a sphere. And here is a rod. Body A, body B. Achha. Here is an inclined plane, angle theta, and then here is a block. This is inclined plane. चलो 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 ड्रॉ करो. So the normal reactions acting on bodies. अच्छा, body A. Look at question number 1. Body A. Is there any normal reaction acting
No.
on body A? Who is applying normal reactions? Body A. Who is applying normal reaction? Ground. It is in touch with ground. So ground is applying normal reaction. Which direction? It's perpendicular to surface. Upward or downward? The ground is pushing it.
Down.
Like this. Not down. Up. The ground is pushing it. Normal reaction is pushing kind of force. So the ground is pushing it. Ground is applying ना. So ground is applying because ground is in contact. Ground contact में है इसलिए ground लगा रहा है. और कैसे लगा रहा है? Push कर रहा है. तो ऐसा होगा. Question number answer 1 समझ में आया तो हाथ उठाओ. If you understood, then raise your hand. Okay, now question number 2. Question number 2 on block A. Tell me how many forces will act on block A?
So two.
Two forces.
Yeah. So one ground is applying. Let's call it as N1. One B is applying. Let's call it as N2. Is that clear? So on
Yes,
block
sir.
A there are two normal reactions
Yes,
acting.
sir.
Achha, on block B how many normal reactions acting? On block B?
So one.
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 Who is applying? Who is applying?
A.
A. Which
A.
direction? Which direction?
Upward.
Upward.
Upward. So block A is pushing. Achha, so it's applying on upward direction. Here comes Newton's third law. Here comes Newton's third law. So B applies normal reaction on A. So A also applies normal reaction on B. So you will always find forces exist in pairs. If object A is applying force on B, then B is also applying force on A. This is Newton's third law. And what are the nature of those forces? The nature of those forces are, what does Newton's third law tell? Newton's third law tells that if A is applying some force on B, then B also must be applying some force on A. कभी भी ऐसा नहीं होगा कि सिर्फ A ही लगा रहा है B के ऊपर और B फोर्स नहीं लगा रहा, ऐसा पॉसिबल नहीं है. If A is applying force on B, that means B also must be applying force on A. Forces exist in pairs. Achha, not only that much, the forces will be equal in magnitude. The forces will be equal in magnitude. है ना? The forces will be equal in magnitude. So don't call it as N2 and N3. See, I am writing both as N2 only. B is applying force on A. If it is N2, then A is also applying normal action on B. How much? N2. Not only that much. So Newton's law, Newton's law. First point, if A is applying force on B, that means B is also applying force on A. Second point, these forces will be equal in magnitude. Third point, the directions will be equal. Directions will be equal. है ना? देखो directions equal है ना? On A it's downward, on B it's upward. That's all. Next point. Next point. Equal in magnitude, opposing direction. They act simultaneously. They act simultaneously. Simultaneously का मतलब क्या है? They act at same time. है ना? At the same time, A is applying force on B and B is applying force on A. And fourth point, they do not cancel each other. They do not cancel each other. Okay. Now let's discuss about this third and fourth point. Let's discuss about this third and fourth point. तो चलो थोड़ा वीडियो ऑन करते हैं, है ना? Let's switch on the video. All of you also can switch on your videos. Am I visible to?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now I am stopping the sharing of the screen. Today we will talk about this much only. So let me stop the screen sharing and let's discuss these 4 points properly. Okay. So stop share. View. Gallery view. Okay. Maybe all of you can also switch on our videos. Let's see. आप लोग हो कि नहीं वो भी मुझे देखना है ना, whether all of you are there or all of you have slept. Okay. So some jokes. Generally, whenever Newton's third law comes, people speak many jokes. One joke related to that. They explain it like this. Now I will tell what is right with that example and what is wrong with that example. So sometimes people tell that if you go and slap a person, then that person also slaps you back. So when you are slapping, that is the action, and when that person slaps you back, that is the reaction. This is Newton's third law. Now this is a wrong example. How? See here when you give this example, there is a misconception. People feel that first you slap and then after some time the reaction comes, that person slaps you back. Actually, it's not like that. You are slapping and that person slapping. They are not action reaction. According to Newton, which are action? You slapped him. So when your hand was touching his, cheek, your hand was applying some force on that cheek, on the face, and the face was also applying some force on your hand. Those two forces are action reaction. They are equal and opposite. They act at same time. That is Newton's third law. So you are slapping and that person slapping. They are not action reaction. Got it? Which are action reaction? When your hand is touching that person's face, that time your hand is applying some force. Your palm is applying some force on that person's face. That person's face is applying some force on your palm. Those are action reaction, and they are equal. They are opposite. and they act at same time. There is no time gap. There is no time gap. So the third point, simultaneously means there is no time gap. It acts at the same time. And fourth point, they don't cancel on each other. This is one more problem with students. They think, action and reaction, they cancel each other. Why? Because their logic is two forces which act equal in opposite direction must cancel each other. No. Let's say here is a pen. Let's say I apply 5 Newton force towards right on this pen. How much? How much?
5 Newton.
5 Newton.
Hello. 5 Newton. Acha. Let's say some of you also apply 5 Newton force on my mobile towards left. How much force I am applying? 5 Newton towards right. How much force you are applying? 5 Newton towards left. Acha. I am applying force on this pen. I am applying this force on this pen. You are applying force on that mobile. Will these forces cancel each other? Will
No, sir.
these
No,
forces?
sir.
No, sir.
But both are 5 Newton and one is towards right, one is towards left. Na? Why they won't cancel?
So you are acting pen and I am acting with
The
mobile.
body is different. And
Yeah, so the body is different. Why they will cancel out? So because of my force, this pen will move. Because of your force, that mobile will move. Why they will cancel? So many times people forget that when we are talking of Newton's third law, two bodies applying force on each other, they don't cancel. Because one force is acting on body A, that will move body A. Another force is acting on body B, so that will move body B. Why they will cancel? Got it? Got it. So this was the fourth point. So I mentioned 4 points about Newton's third law. 4 points about third law. Who can tell 4 points about third law?
Sir, direction will be equal to your authority से बुझेगी.
On body A, let's say in this question, body A and body B. Body A is below, body B is on top. Now on body B, what is the direction of normal reaction? It's upward. On body A, what is the direction of normal reaction by B? It's downward. So on body B, normal reaction acting. It's acting. Who is applying? A. Which direction? Upward. So on body A, normal reaction is acting. By whom? By B. And B is applying this direction? Downward. Got it?
Yes.
Or let's say here is Earth. Here I am there. So now I am here. On me, Earth is applying gravitational force. Which is direction? Downwards. Okay. So similarly, I can tell on Earth, I am applying gravitational force. Which direction? Upward. Forces always exist in pairs. Acha, what are the 4 points about third law? Who can tell?
yes, sir.
4 points
I can-
about third. Yeah, Akanksha. Yes, tell.
Sir, Ipsita.
Acha, Ipsita, tell.
Yes, sir. If one body apply force on other body, then the other body is also apply force one body, and forces are equal in magnitude and direction will be equal. The force
Direction opposite. Direction will be opposite.
direction will be opposite, and the forces act simultaneously, and they don't cancel each other.
Yeah. One more thing. Many times people fail. This is another misconception. So understanding means understanding a subject. मैंने ये समझ लिया. इसका क्या मतलब है? मतलब you should know the concepts. सही क्या है? You should know the misunderstandings. इसमें गलत क्या है? बच्चे क्या गलती करते हैं? That also you should remember. If you remember बच्चे क्या गलती करते हैं, तो फिर आपका वो गलती नहीं होगा. Got it? If you be careful कि इसमें बच्चा मिस्टेक क्या कर सकता है, तो फिर आपका वो मिस्टेक नहीं होगा. This is a very good way of minimizing mistakes. Be conscious. We always think what mistakes students do in this, what mistakes students can do in this. Then you will see you won't do that mistake. Your mind becomes conscious कि such a mistake exists and let me not do that. Got it? So one of the mistakes people think, like in this question, body B is kept on body A. So people think because body B is kept on body A, so body B will apply its weight on body A. This is a wrong concept. There is nothing like that. If a body is kept on some other body, then that body will apply its weight on the other body. For example, people think I am sitting on the chair. I am sitting on the chair. So people think because I am sitting on the chair, I am applying my weight on the chair. ऐसा कोई concept है ही नहीं, पता नहीं ये कहाँ से आ गया. These are all misconceptions. कोई अपना weight दूसरों के ऊपर नहीं लगाता. I am sitting on the chair, so I am in contact with the chair, so I am applying normal reaction on the chair. That's the concept. That normal reaction may be mg, may be greater than mg, may be less than mg. Got it? I don't apply my weight on chair. No one applies its weight on some other body. People means bodies apply normal reaction on each other. We don't apply weight on each other. We apply normal reaction on each other. How many of you understood this point? Raise your hand. And then if you want to give in afternoon, you give in afternoon, but give in front of your parents. And then as soon as you finish the test, send us the question back. Send us the answers. Photo click करके भेज दो उसको. ठीक है?
Yes, sir.
Yes, sir.
Okay. चलो, bye.